Hello and welcome to the channel. In today's video, we're taking a look into the realm of solar energy. We'll be discussing the fundamentals of solar power, its advantages and drawbacks, and delving into the underlying science. So let's dive right in. But first, if you enjoy this kind of content, feel free to like the video and subscribe to the channel. So let's start with the basics. Solar energy comes from the sun and is a renewable source of energy. We capture sunlight and convert it into electricity or heat for various uses. The central player in this process is the solar panel. These panels contain photovoltaic or PV cells, typically made from silicon. When sunlight hits these cells, they generate electricity, a way of turning sunlight into usable power. Now, let's demystify the science behind solar panels. When sunlight interacts with the PV cells, it causes electrons within them to become excited. This excitement generates an electric current, which can then be harnessed and converted into electricity. So how did the PV cells pull off this feat? It's all thanks to the photovoltaic effect. When sunlight, which is made up of tiny particles called photons, strike the surface of a PV cell, it releases energy. This energy excites the electrons within the semiconductor material. Imagine it like this. The photon is like a cosmic game of billiards, bumping into electrons and knocking them out of their usual positions. This energy boost turns these now excited electrons into a high energy state. With these electrons all amped up, they start to flow within the semiconductor material, creating an electric current. This flow is the key to generating electricity. Think of it as a dance party where electrons move from one spot to another. But here's the clever part. PV cells are designed with specific layers to guide these excited electrons. The top layer has extra electrons and the bottom layer is eager to accept them. So, as the electrons move from high energy to low energy zones, they create an electric current. It's a fascinating way in which a natural phenomenon like sunlight is being tapped to power modern technology. Next, let's explore the benefits of solar energy. One major plus is its eco-friendliness. Solar energy doesn't contribute to pollution or emit harmful gases like fossil fuels, which is a definite positive for the environment. Additionally, solar energy is renewable. The sun isn't going anywhere soon, so we won't run out of this source. Plus, it offers a certain degree of energy independence. By generating your own electricity, you can reduce reliance on the grid and potentially lower your energy bills. And while solar panels do require an upfront investment, there's potential for long-term savings as your energy bills decrease. However, it is important to note the downsides of solar energy too. One major challenge is its intermittency. Solar power generation depends on sunlight, so cloudy days and nighttime can affect its reliability. This means backup energy sources might be necessary. Initial costs can also be deterrent. While prices have decreased, setting up solar panels still requires an investment. But before you rule it out, consider the various incentives and financing options that are available. Looking ahead, solar energy is evolving. Researchers are working on making solar panels more efficient, while energy storage solutions like batteries are being developed to address the intermittency issue. The integration of solar power into various technologies, from gadgets to vehicles, holds potential for further growth in this field. To wrap it up, solar energy has a solid place in our energy landscape. It's a resource with its share of strengths and limitations, and understanding these aspects is essential in assessing its practicality. Thanks for watching, and I'll see you in the next one.